independent random variables. Independent random variables. These are some of the best random variables there are. I love independent random variables. Okay, so recall the events A and B are independent if and only if the probability of A given B is the probability of A. That is, information of B occurring doesn't change the chance of A occurring. And of course, and this is equivalent. We showed that this was equivalent to the chance of B given A equals the chance of B, and which is also indeed equivalent to the chance of both A and B occurring was the product of the chances of the individual events, right? Yeah. Okay. All these three things are actually equivalent. If any of these hold, then A and B are independent. So I'm going to focus on this one right here for a minute. Okay. I'm going to look at this. So what if instead of events here, maybe we're concerned with random variables. Well, what if I want to talk about the chance that x is less or equal to little x and y is less or equal to little y? Then if this turns out to be the chance that x is less or equal to little x times the chance that y is less than or equal to little y, then what this means is that these events are independent, right? If this holds with equality here, if this statement is true, then the events that x is less or equal to x and y is less or equal to y are independent. Maybe I should put those in braces. Are independent. Okay? So we're just talking about independent events. So sometimes, though, when we're dealing with random variables, we talk about random variables being independent. Okay, and we do that if so we'll say that the random variables x and y are independent. If the probability that x is less or equal to x and y is less or equal to y, which is, in fact, we know that this is this can be written as the joint CDF of the two variables evaluated at x and y. If this can be written as the product of the marginal CDFs evaluated at x and y respectively, okay? Which is, this is in fact just this, right? Same thing. But this is for all x and y. For all little x and y, okay? All right, so note the difference here. On one hand, we've got events. On the other hand, we've got variables, random variables. Random variables are functions, okay? And these are special kinds of events. It says that the random variable is less or equal to little x, and that the random variable y is less or equal to little y. So, but anyway, it does motivate the terminology here to talk about independent random variables. These random variables are independent if the joint CDF can be written as a product of CDFs for all x and y. Okay. All right. So here's a theorem for you, and we aren't going to prove it. You can find it in a book, but x and y are independent random variables if and only if and only if the joint probability mass function is equal to the probability of the marginal probability mass functions for the discrete case, x and y discrete. Or the joint density function can be written as, can you guess? The product of the marginal density functions. For x and y continuous. Okay? So this is really fantastic. This is really fantastic.